Hi, I'm Mark Bury with Master Builder Solutions, and the presentation I'm going to be sharing today is on low carbon concrete case studies. So sustainable green concrete is an environmentally preferable, cost-effective advanced concrete where we use recycled materials combined with chemical admixtures to exceed engineering and environmental performance targets. And one of the keys to producing green concrete is replacing a portion of the cement with a recycled powder to minimize the environmental impact of that concrete. And this recycled powder can be common materials such as fly ash, slag cement, limestone fines, or other similar common materials. However, in order to achieve this desired concrete performance, simple cement replacement is not sufficient. Highly advanced chemical admixture technology that's designed and manufactured at the molecular level is typically used in conjunction with very sophisticated and proprietary proportioning techniques, computer analysis, material science, and behavioral knowledge. It's all critical, and it's required to develop unique and customized green concrete mixture designs. Some of these admixture technologies consist of polycarboxylate-based water reducers, viscosity modifying admixtures, rheology modifying admixtures, and workability retaining admixtures. And here are a few examples of case studies using low carbon concrete. So let's start on the East Coast. This is One World Trade Center. The owner was the Port Authority of New York and New Jersey. And in this particular project, up to 74% of the Portland cement was replaced using a combination of fly ash, slag cement, and silica fume. In fact, the environmental savings on this project was so great, it was awarded the Green Site Project of the Year for high performance green concrete. Moving over to the West Coast of North America, this is the City of and County of San Francisco service building. It's a LEED platinum building, and in this case, up to 70% of the Portland cement was replaced, yielding a CO2 emissions of 7.4 million pounds or 3.4 million kilograms of net savings of CO2. If you move back to the East Coast, this is the highest residential building in North America. It's 432 Park Avenue. And in this particular project was really unique in that the architect wanted a white structure. So metakaolin was used as a Portland cement replacement, up to 72% of that cement. So the building remains white and very architecturally attractive. And you can see on the slide here, the energy usage, greenhouse gas emissions, water emissions, and solid waste had significant environmental savings by replacing that Portland cement. If you move over to the eastern part, or the central part, excuse me, of the U.S. This is the Reed high-rise building that employs low-carbon concrete. And this is a 41-story, 440-unit luxury residential tower designed by Perkins & Will for Lend-Lease's South Bank project in Chicago. And the cement replacement for different concrete mixes in this project ranged from 65% to 73%. And there were 28,000 cubic yards or 21,000 cubic meters, approximately 3,000 or 3,100 concrete trucks delivering concrete to this project. So a large project. There was a quote from Ten Weldon, the executive manager of development at the Lend-Lease Chicago, who indicated low carbon concrete and sustainable features in general are highly marketable. And part of his quote was, increasingly, they're seeing clients and investors that are seeking sustainable building construction. To kind of put this in some context for the Reed residential tower, here are some savings, equivalents. For CO2, for example, that's the equivalent of 68,000 gallons of gasoline consumed, or 8 tanker trucks worth of gasoline. Or another way to look at it is almost 74,000 cell phones that were charged. That's the equivalent CO2 emissions savings. Yeah, or also another way to look at it is the savings here were equivalent to greenhouse gas emissions. They were avoided by 70 or 26,000 trash bags of waste that were recycled instead of landfilling, or equivalent savings to the carbon sequestered by 10,000 tree seedlings grown over 10 years. So you can see when you start to put this in context, it's quite a bit of savings. And to finish up our presentation today, this is not only can be employed in iconic structures around the world, for example, as you see here, the Shard in London, the Kingdom Tower in Jeddah, Saudi Arabia, the Shanghai Center Tower. All of these iconic skyscrapers employed the use of advanced mix optimization, some of these chemical admixture technologies to save anywhere from 50 to 72% cement replacement. And so one takeaway here is it's not only just these iconic structures, but you can use these same techniques in residential construction and everything else in between. So I hope you enjoyed this presentation today as a snapshot of sustainable green concrete and what's possible using today's admixture technology and advanced mix optimization techniques. Thank you.